Lesson 1, Trig equations. To solve trig equations, utilize the same processes used to solve linear or quadratic equations. We're going to add, subtract, multiply, or divide on both sides of the equal sign to isolate the variable. Then we're going to factor or use the quadratic formula if necessary. Once you solve the equation over the specified domain, look up the answers from the exact unit circle coordinates. Solve each trigonometric ratio in the specified domain. So A is 5 sine theta plus 2 equals 1 plus 3 sine theta. So let's just rewrite that. I have 5 sine theta plus 2 equals 1 plus 3 sine theta. So my variable is sine theta. I need to try and get that expression by itself first. So we're going to move the sine thetas to the left and the numbers to the right. So I'm going to subtract 2 from both sides. I have 5 sine theta equals negative 1 plus 3 sine theta. I'm going to subtract 3 sine theta from this side and this side. If I have 5 sine theta and I subtract 3, I'm left with 2 sine theta on the left, and on the right I have negative 1. Divide both sides by 2, and we have that sine theta is equal to negative 1/2. So I'm looking for all values of theta that have a sign of negative 1/2. You're now going to go to your unit circle exact value table, and you can find then that the sine of pi over 6 is equal to 1/2. But we want where sine is negative. And so sine is negative in quadrants 3 and 4. So in quadrant 3, we're looking for an angle that's down here. So we want to come this far is pi plus pi over 6. So pi plus pi over 6. To add those two, we need a common denominator, so I can make this 6 pi over 6. And we end up with 7 pi over 6 as one possible answer. Another solution, in quadrant 4, we'd be looking at coming all the way around to here, where this little angle in here is pi over 6. And so we'd actually go a full revolution, or 2 pi, minus pi over 6. Well, 2 pi is 12 pi over 6, and so we end up with 11 pi over 6 as our second answer. Our domain is at one full revolution, so between 0 and 2 pi, so we only have the two answers. 3 cosecant x minus 6 equals 0. I need to get the trig function with the variable by itself, so I'm going to add 6 to both sides. I end up with 3 cosecant x equals positive 6. Divide both sides by 3. And we end up with the cosecant of x is equal to 2. Well, I know that cosecant is actually equal to sine, the reciprocal of sine, so sine x then must be 1 over 2. Going to our unit circle exact values will help us find that the sine of 30 degrees is actually 1/2. We want it to be positive, and sine is positive so it's greater than 0 in quadrants 1 and quadrant 2. So in quadrant 1, then we have that the sine of 30 equals 1/2. So then x, our angle, is 30 degrees. In quadrant 2, we're looking for the angle here. We're going to do 180 degrees minus 30 degrees, so 150 degrees. Don't forget to put your degree symbol in for angles that are measured in degrees. This one says give solutions as exact values where possible. Otherwise, give approximate angle measures to the nearest thousandth of a radian. So we're going to factor this one similar to factoring x squared minus 5x plus 4 equals 0. So you can think of it as substitution if you want. But what I'm doing is I'm replacing the tan theta with a variable. If we were to factor x squared minus 5x plus 4, we would find our two factors to be x minus 4 and x minus 1. In this case, we don't have x, we actually have tan theta, and so we have tan theta minus 4 and tan theta minus 1 equals 0. Gives me two possible solutions, one where each factor is equal to 0. So the first one then becomes tan theta equals positive 4, or tan theta equals positive 1. In both cases, we want where tangent is greater than 0. Tangent is greater than 0 in quadrants 1 and quadrant 3. Remember that you can use your cast rule to figure that out, or other methods. So let's look at this first possible solution. To find theta when tan theta equals 4, we don't have any possible exact values. So you're going to use your calculator, and when you do that, make sure that your calculator is set to radians. You will find that theta is approximately 1.32 radians. In quadrant 3, we would have to do pi plus that value, and so we'd end up with an approximate value of 4.467 radians. So there's two possible solutions. Now, from this other side, we want values where tan theta is equal to 1. Well, I know that the tangent of pi over 4 is equal to 1. So in quadrant 1, then, theta would just be pi over 4. In quadrant 3, theta would be pi plus pi over 4. Pi plus pi over 4 is 5 pi over 4, would be the other solution. So I actually end up with 4 different solutions this time. Remember that one full circle is 360 degrees, or 2 pi radians. To determine the general solution, or if your domain is in the question is all real numbers, first find the solutions in one rotation, then use the concept of coterminal angles to write an expression that identifies all possible measures. Let's look at an example. It says solve for x in the interval of 0 to 2 pi if sine squared x minus 1 equals 0. So this is exactly the same as what we have been doing. So if I have sine squared x minus 1 equals 0, I can factor it, or I can solve it as a square root equation. If I factor it as a difference of squares, I end up with sine x minus 1 and sine x plus 1. So I have then that sine x is equal to positive 1, or sine x can equal negative 1. Where sine is equal to positive 1, well, sine is our y value, and so if we think of that unit circle, we have y values of positive 1 up here, and a y value of negative 1 down here. So at this top point where sine is positive 1, or the y value is positive 1, that angle is pi over 2. So in quadrant 1, I guess it's not really a quadrant, our first solution here is pi over 2. For sine x equals negative 1, so what angle has the sign of negative 1? That angle is for this point down here, so from here all the way around, that angle, x would have to be equal to 3 pi over 2. So there's our two possible solutions within one revolution. Part B asks us to determine the general solution. So for part B, what we're now going to do is add full revolutions. So it's pi over 2 is one possible solution, and then we can add or subtract full revolutions, and remember that n is the natural number. So I can go around one time, and it would be 2 pi times 1. I can go around twice, and it would become 2 pi times 2. Our other solution is that 3 pi over 2 has to be plus or minus 2 pi n.